today we are going to be going over the second half of number theory AMC 8 problems. So it doesn't look like Benjamin's here yet, so if you guys have any questions, please message them to me privately. So this is the first question I think we didn't do last time, so I'll give you guys a few minutes to try this. Yeah, I also sent these problems ahead of time a few days ago, and that's just for people who thought that maybe we were going a bit fast and they didn't have time to try the problems. If you already did the problems, then today's class will be a good way to see any alternative solutions that you might not have came up with or to check your answers. Okay, so I'm gonna go ahead and get started here. The question is asking how many positive 3-digit integers have a remainder of 2 when divided by 6, a remainder of 5 when divided by 9, and a remainder of 7 when divided by 11. So the way this is written as is if you let x be your 3-digit integer, then that means that x would be congruent to 2 mod 6. And x would be congruent to 5 mod 9. And x would be congruent to 7 mod 11. So basically, mod means that when you divide it by that number, what's the remainder? So for example, here it says it has a remainder of 2 when divided by 6. And that would be the same thing as saying x is congruent to 2 mod 6. So the triple equal sign means congruent. Oh, hang on, Benjamin's here. Okay, so yeah, let me make Benjamin co-host. Okay, looks like we're all set. Okay, so that's what mod basically means. So, and you'll notice that 2 mod 6, 5 mod 9, and 7 mod 11 actually have something in common, because you'll notice that 6 minus 4 is 2, 9 minus 4 is 5, and 11 minus 4 is 7. So instead of writing this, for example, as 2 mod 6, you could also say that this is negative 4 mod 6. And instead of saying 5 mod 9 or 7 mod 11, you could say negative 4 mod 9 or negative 4 mod 11. So essentially, we know that x is negative 4 mod either 6, 9, or 11. So actually, all we have to do is find the LCM of 6, 9, and 11 and just subtract 4 from it. And that would be a possible x. So can anyone tell me what the LCM of 6, 9, and 11 is? Okay, so it looks like 198. So for anyone that doesn't know, LCM stands for least common multiple, and it means the smallest number that's a multiple of 6, 9, and 11. So if you take any of the integers 6, 9, and 11 and you multiplied it by some whole number, you would get that number. So people are saying that the LCM is 198. So 198, when you subtract 4, should give you 194. So this is actually the smallest possible x that works. So we found one number, and remember, it has to be 3 digits. So 194 is our smallest number. And in order to get our next smallest number, what would we do? Well, we could just add another 198, right? So our next smallest number would be 194 plus 198. And you could keep doing this. You could do 194 plus 2 times 198, and then 194 plus 3 times 198, dot, dot, dot. And since they're only asking for those that are 3 digits, you have to stop before you reach 1,000. So the smallest actually here is, I believe, 194 plus 4 times 198. And this here gets you actually just shy of 1,000, which means you can't go over it. So ultimately, there are 5 numbers. 1, 2, 3, 4, 5. So the answer is E. So if you guys had any questions with this problem, don't forget that you can message Benjamin and he can help you out. So I'm just going to move on to the next problem here. A box contains gold coins. If the coins are equally divided among 6 people, 4 coins are left over. If the coins are equally divided among 5 people, 3 coins are left over. If the box holds the smallest number of coins that meets these 2 conditions, how many coins are left when equally divided among 7 people? Okay, so we have some answers, so let's get started. So equally divided among 6 people, 4 coins are left over. So this means that if you give all 6 people the same number of coins, let's say you give each person A coins, then 6 A coins would be used because each person you give A, and there's 6 people in total, and 4 coins are left over. So 6A plus 4 is the total number of coins you have. Let's call that X. And if the coins are equally divided among 5 people, 3 coins are left over. So let's say in this scenario, you give each of the 5 people B number of coins. Then 5B plus 3 would be the number of coins you have, which is X. Note that A and B are actually not necessarily equal. So now they're asking if the box holds the smallest number of coins that meets these two conditions, how many coins are left when equally divided among 7 people? So basically they want you to divide X by 7 and see what the remainder is. So we know that 6A plus 4 is equal to 5B plus 3. And if you simplify this a little, you'll get 6A plus 1 is equal to 5B. So at this point, it's kind of about guess and check. So you have to kind of find the A and B that satisfy this equation. The smallest A and B, because note they ask for the smallest number of coins. And if you do a little guesswork, then essentially I think you'll come out at A equals 4 and B equals 5. So I'm pretty sure this is the smallest one, right? So basically, A equals 4, B equals 5, and if you're dividing this among 7 people, let's first figure out how many coins you have. So you could use this and plug it into either of your equations here. So 6 times A, 6 times 4 plus 4, or 5 times B plus 3, 5 times 5 plus 3. This will give you the same number, and they're both equal to 28. So you have 28 gold coins. So if you equally divide them among 7 people, then you'll have nothing left, since 28 is a multiple of 7. Okay, so let's move on to the next problem. The digits 1, 2, 3, 4, and 5 are each used once to write a 5-digit number PQRST. The 3-digit number PQR is divisible by 4. The 3-digit number QRS is divisible by 5. And the 3-digit number RST is divisible by 3. What is P? Okay, so I'm gonna go ahead and get started. Okay, so note that when they say 5-digit number PQRST, P, Q, R, S, and T are the 5 different digits. So this doesn't mean P times Q times R times S times T. And normally in math problems, they would put a bar over it. So a bar over PQRST would mean that those are digits and not you're just multiplying them together. So you have to use 1 through 5. And note that they say the 3-digit number QRS is divisible by 5. And the only way something can be divisible by 5 is if it ends in 0 or 5. So right away, you know that S is 5 because you don't have a 0. P, Q, R, 5T. So once you've used this piece of information, you can actually just delete it from your mind because you already know that S is 5. So next, they're saying the 3-digit number PQR is divisible by 4. So this number here is divisible by 4, and RST is divisible by 3. And remember that you have the numbers 1, 2, 3, and 4 left. So in order for something to be divisible by 4, the last 2 digits have to be divisible by 4. So since the last 2 digits have to be divisible by 4, the only way we can create multiples of 4 out of these 4 numbers are 12, 24, 32, and that's it. So if we plug each of these in for QR, for example, if we plugged in 12, we would get P1, 2, 5T. And at this point, we have either 3 or 4 left over. So since they say RST is divisible by 3, R plus S plus T, or these 3 numbers, added together, has to be a multiple of 3. So 2 plus 5 is already 7. So to get to another multiple of 3, adding 3 or 4 would not work. So you would know that this is not the answer. So next you can try 2, 4. So that would be P, 2, 4, 5T. So once you use 2, 4, then the only numbers you have left are 1 and 3. So 4 plus 5 plus T has to be a multiple of 3. And the only way that would work is if T was equal to 3. So we find that the number 1, 2, 4, 5, 3 would actually work because it satisfies all the requirements. So the next case you can do is 3, 2. So this would be P, 3, 2, 5T. And at this point, once you use 3 and 2, only the numbers 1 and 4 would be left. And so 2 plus 5 plus T has to be a multiple of 3. And adding 1 would not work. And adding 4 would not work. So it turns out that this doesn't work either. So actually, the only way that works is this. And since they're asking what is P, you can go back here and say that P is the first digit, and the first digit here is 1. So therefore, the answer is A. Okay, so let's move on to the next problem. In how many ways can 10001 be written as the sum of 2 primes? Please don't spam answers to me. I know it's kind of fun, but please refrain from doing that. Okay, so let's get started. So this is actually kind of an easy problem. All you have to do is look at parity, which is whether it's even or odd. So we have the number 10,001 here. And note that 10,001 is an odd number. And they're asking you to write this odd number as the sum of two primes. Well, an odd number can either be a sum of an even number or plus an odd number. And you cannot get an odd number by adding together two evens or two odds. So this is the only way that would work. And unfortunately, the only even prime is 2. So this would have to be 2. And since this is 10,001, that would mean that the other number in this equation would have to be 9999, right? And note that 9999 is not a prime because it is clearly divisible by a lot of things. It's divisible by 3, it's divisible by 9, it's divisible by 1111. So we can safely say that there are 0 ways to do this. So that was kind of an easy problem. And also, it's a good time for a trick on the AMC 8s. So because the problems on the AMC 8 are not necessarily arranged in order from easiest to hardest, it's always good to look at the last few problems, even if you might not get to them in the actual competition, because there might be some easy ones like this one. AMC 8 is for 8th grade and under, yeah. Okay, how many perfect cubes lie between 2 to the 8th plus 1 and 2 to the 18 plus 1 inclusive? Okay, so let us go ahead and get started here. So you'll notice that 2 to the 8th plus 1 is actually equal to 2 to the 8. Can anybody tell me what 2 to the 8 is? Okay, good. So 2 to the 8 is 256. So 256 plus 1 is equal to 257. And can anybody tell me what 2 to the 18th is. Just kidding, don't do that. Okay, so 257. What is the smallest perfect cube that is above 257? Well, if you kind of try some things, you'll find that 6 cubed is not quite there, but 7 cubed passes this easily because 7 cubed is equal to 343. So here is the first cube. And let's try to find what the last cube is. Well, 2 to the 18 plus 1 can be written as 2 to the 6 cubed plus 1 is equal to 64 cubed plus 1. So this is just slightly above 64 cubed, which means the last cube that works is 64 cubed. And note that you don't actually need to calculate what 64 cubed is in order to get the answer. So if you start at 7 cubed and you end at 64 cubes, then how many perfect cubes lie in between those two? Well, it's just 64 minus 7 plus 1. So 64 minus 7 plus 1 is going to give you 58. And that answer is E. Okay, so moving on to the next problem. A baseball league consists of 2 4-team divisions. Each team plays every other team in its division N games. Each team plays every team in the other division M games, with N is greater than 2M and M is greater than 4. Each team plays a 76-game schedule. How many games does a team play within its own division? Okay, so let's get started. So let's just try to draw a picture of all the teams. So on the left side here, you have 2 4-team divisions. So in the first division, you have 4 teams. Let's say they're A1, A2, A3, and A4. So in the right side, you have another 4 teams in a separate division, B1, B2, B3, and B4. Okay, so each team plays every other team in its division n games. So if you look at, for example, team A1 here, they play with A2, A3, and A4. And each of those times they play n games. So that is 3 times n times. So each team also plays every team in the other division m games. So A1, for example, plays with B1, B2, B3, and B4. So it plays with those 4 teams, and each time it plays m games. So 3n plus 4m is the total number of games that team A1 plays. And we're told that each team plays a 76 game schedule, which means this is equal to 76. How many games does a team play within its own division? Okay, so basically, they're asking for 3 times n because it plays 3 teams in its own division each n times. So really, it's asking for this number. So at this point, you have one variable, 2 variables, 1 equation. So you kind of have to guess and check a little. So they tell you that m is greater than 4. So you can try at m equals 5. And at m equals 5, you get 3n plus 20 is equal to 76. And this is impossible because 76 minus 20 is not divisible by 3. So then you might try m equals 6. 3n plus 24 is equal to 76. And you'll find that still it doesn't work because 76 minus 24 is 52, and that is not a multiple of 3. So next you could try 7. So 3n plus 28 is equal to 76. And here, if you subtract 28 on both sides, 3n is equal to 48. So if 3n is equal to 48, then n is equal to 16. And basically, you have the answer because they're asking you for 3 times n, and that number is 48. Okay, so let's move on to the next problem. What is the correct ordering of the 3 numbers 10 to the 8, 5 to the 12, and 2 to the 24? Okay, so the first thing you have to do is simplify the numbers they give you. So for example, 10 to the 8 is equal to 2 to the 8 times 5 to the 8, because 2 times 5 is 10. And they're asking you to compare this number with 5 to the 12 and 2 to the 24. Okay, so The easiest thing to notice here would be that 2 to the 24 is actually equal to 2 squared to the 12, which is equal to 4 to the 12. So 4 to the 12 is obviously less than 5 to the 12, which means that 2 to the 24 is less than 5 to the 24. So that immediately eliminates some options. So that eliminates C. That eliminates D. And that is it. Okay, so the next thing you can notice is that, oh, hang on. Someone asked, is it possible at the end to go back? I'm not sure what you mean by that, but this lesson is being recorded and it'll be uploaded to the YouTube channel later. Oh, back to the previous question. Do you have any specific questions about that problem? It would be better if you asked Benjamin. Yeah. Someone asks, what's the YouTube channel? So if you just go to YouTube and just search Alphademic Learning, then you'll be able to find it. Or if you go to youtube.com slash Alphademic Learning. Okay, so back to the problem here. So now you need to bring 2 to the 8 times 5 to the 8 into the inequality. And the first thing you can notice is that if you compare these two, you'll notice that 5 to the 12 is equal to 5 to the 4 times 5 to the 8, which means that 5 to the 12 is 5 to the 4 times greater than 5 to the 8. And if you look at 2 to the 8, then you'll find that 2 to the 8 is equal to 64. Oh, hang on, that's not 64. 256 times 1, which means that this number here has 256 times the number of 2's that this one has. But this one has 5 to the 4 times as much as this one has in terms of 5's. So really you have to compare the numbers 5 to the 4 and 256. So 5 to the 4 is actually 625. So if you compare 625 and 256, you'll find that 625 is greater, which means that ultimately 5 to the 12 is greater than 10 to the 8. And so that ultimately means that you can eliminate some more options here. You can eliminate B, which says that 5 to the 12 is less than 10 to the 8. Okay, so now you are down to A and E. So really the difference between A and E is that it compares 2 to the 24 with 10 to the 8. So let me just erase some stuff here. Okay, so don't forget that 10 to the 8 is 2 to the 8 times 5 to the 8. So 2 to the 24 has 24 minus 8 equals 16 more 2's than 10 to the 8 does. And 2 to the power of 16 is a big number. But you'll also notice that 10 to the 8 has 8 more 5's than 2 to the 24 has, which means it's 5 to the 8 power bigger on that side. But if you change 2 to the 16 and rewrite it as 2 squared to the 8 equals 4 to the 8, you'll notice that 5 to the 8 is now obviously greater than 4 to the 8, which means that 10 to the 8 is ultimately greater than 2 to the 24. So I know that might have sounded kind of confusing, but it's kind of like a seesaw. Basically, which side has the bigger number, and that's the heavier side. So the 5 to the 8 bigger that 10 to the 8 has ultimately outweighs the 2 to the 16 bigger that 2 to the 24 has, which means that 10 to the 8 is greater. So that eliminates choice E, which means the answer is A. Okay, so let's move on to the next question. Calculators are not allowed on the real test because obviously it would turn problems like this into very easy problems. Yeah. Okay, so next question. The diagram represents a 7-foot by 7-foot floor that is tiled with 1 square foot black tiles and white tiles. Notice that the corners have white tiles. If a 15-foot by 15-foot floor is to be tiled in the same manner, how many white tiles will be needed? Okay, so let us start. So it's actually kind of relatively simple to notice a pattern here. So for example, if you will see a 1 by 1 floor, if you have a 1 foot by 1 foot floor, then how many white tiles would you need for that? Right, obviously 1, because that's just this little piece of floor right there. If you had a 3 by 3 floor, how many white tiles would you need? Right, you would need 4. Because if I draw 3 by 3 here, you can count 4 white tiles. And if I needed a 5 by 5 floor, how many white tiles then? Yep, you would need 9. And 7 by 7, you can count in the figure, would be 16. So at this point, it's kind of obvious to see the pattern here. Because you can see that 1, 4, 9, and 16 are perfect squares. So if you scale that up, then a 15 by 15 foot floor would have a perfect square number of white tiles too. And if you scale it up, you'll find that 9 by 9 would give you 25. And 11 by 11 would give you 36. And 13 by 13 would give you 49. And finally, 15 by 15 would give you 8 times 8, which is 64, or C. Okay, so let's go on to the next problem. Each of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 is used only once to make two 5-digit numbers so that they have the largest possible sum. Which of the following could be one of the numbers? Okay, I'm getting all types of answers. So the key to doing this problem is that you don't actually want to try every single combination and try to make the biggest. But if you notice that the biggest numbers that you can make always result when you put the biggest numbers in the higher place values. So if you are trying to construct two different numbers, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, then putting the 9 here and putting the 9 here are two very different things. Because putting the 9 here in the ones place only gives it a plus 9. And putting the 9 here in the very first place actually gives you a plus 90,000. So there's kind of a big difference. And you want to give the bigger numbers like 9 in the higher places because, for example, if you have a 1 here or a 1 here, a 1 in the very first position here would give you 10,000. And a 1 in the least digit position there would just give you a plus 1. And the difference between a 9 and a 1 is much smaller than the difference between 90,000 and 10,000. So you always want to put the bigger numbers to the left in order to create the bigger number. So if you follow that principle, then you can immediately eliminate some answer choices because each of the 5-digit numbers, their digits have to go from biggest on the left to smallest on the right. So, for example, you can easily eliminate B because in B it jumps from 6 to 7. So that's an increase, not a decrease. And similarly, you can delete D because its digits jump from 2 to 4. So that's an increase again. And you can also delete E because the digit jumps from 0 to 3, and that's an increase, not a decrease. So you really can narrow it down to either A or C. So when they're asking for the largest possible sum, and honestly, at this point, you could actually just try to add up the numbers. Like for example, if 76531 goes here, then you know that 98420 goes here, and you can add it and compare it to the other one. But if you want to be smart about it, then you'll notice that this is not actually the most efficient way to order the digits. It would be much better, instead of having a 9 in the most valuable place and a 7 in the most valuable place, you could have a 9 there and you could have an 8 there. Okay, so the reason why we know that the numbers have to go in decreasing order is that if they went in increasing order, if at some point you had, for example, 1, 2, hang on. So for example, if you had, for example, 5, 4, 3, 6, if you made a jump from 3 to 6, that would always give you a smaller number than if you switch the two. So 5, 4, 6, 3 would always be bigger than 5, 4, 3, 6. Because you want the bigger numbers like 6 to the left, and you want the smaller numbers like 3 to the right. I mean, they are asking for the greatest sum because it says here largest possible sum. But the largest possible sum you always get if you add the two largest possible numbers. So in order to maximize the largest possible sum, you have to put the biggest numbers to the left. So it either starts with a 9 and then 8. And that basically eliminates choice A because that starts with a 7. So you have C. Okay, next problem. The hundredths digit of a 3-digit number is 2 more than the units digit. The digits of the 3-digit number are reversed, and the result is subtract from the original 3-digit number. What is the units digit of the result? Okay, so with these types of problems, you see that the only requirement they have is that the hundredths digit is 2 more than the units digit. And that's the only requirement there is, basically. So that means that any number you can come up with where the hundredths digit is 2 more than the units digit will work. So for example, let's say our hundredths digit is 3 and our units digit is 1. So we have, for example, some random number in the middle, let's say 5. So if you reverse the digits, you get 153. And if you subtract the two numbers, then you will get 1 minus 3 for the units digit, but the 1 will obviously borrow. So that becomes 11. And 11 minus 3 is 8, which means your answer is 8. Okay, so next question. The 7-digit numbers 74A52B1 and 326AB4C are each multiples of 3. Which of the following could be the value of C? Okay, so in order for a number to be a multiple of 3, the sum of its digits have to be a multiple of 3 too. So let's just add the digits of each of these numbers. So for our first number, you get that 7 plus 4 plus A plus 5. Hang on, that was a bad A. Plus A plus 5 plus 2 plus B plus 1 is a multiple of 3. So if we simplify this, why do we need to know 7, 4, A, 5, 2B, 1? Well, if you just try to do it on the last number, you would get A plus B plus C plus some constant is a multiple of 3. And that would be too many variables. Because if you're trying to figure out what C is and you don't know what A and B are, then you'll be stuck. So you really need to figure out what A plus B is using the first number. So if you simplify this, you'll get A plus B plus 7 plus 4 is 11, 5 plus 2 is 7, and you have a 1 here. So that's 11 plus 7 plus 1, which is 19. So this is the sum of the digits of your first number. So you're told that this is a multiple of 3. So let's just leave that for now. We know that this is 3 times something. Let's just say, for example, m. So let's leave that and let's go to the second number. So we know that 3 plus 2 plus 6 plus A plus B plus 4 plus C is a multiple of 3. And simplifying this, A plus B plus C plus 4 and 6 make 10. And 3 plus 2 is 5, so that's a 15. You know that this is also a multiple of 3. For example, 3 times the number n. So 15 here is obviously a multiple of 3, so you can actually ignore that. Because we know that A plus B plus C has to be a multiple of 3. So what this equation tells you, hang on, let me use a different color. So what this equation tells you is that 19 leaves a remainder of 1 when you divide it by 3. So if you actually move 19 to the other side, then you'll get that the number A plus B is equal to 1 less than a multiple of 3, right? And in formal notation, this would mean that A plus B is congruent to 2 mod 3. Does everybody understand that? Okay, so since you know that A plus B is 2 mod 3, and that number plus C is equal to another number that's a multiple of 3, or you could say that this is 0 mod 3, or even 3 mod 3, then you know that C has to be 1 mod 3. Which means that C divided by 3 leaves a remainder of 1. And there's only one number in the answer choice that when divided by 3 leaves a remainder of 1, and that is A, which is 1. So technically, I believe it is 7 o'clock, so unfortunately, I don't think we got to all of the problems. Let's just take a look. So we have this problem, and we have this problem, and that's actually it. Do you guys want to end it here, and I can send you guys the 2 problems for you to try by yourselves? Okay, sure. The majority of people are saying send it, so that's what I'm gonna do. So on Google Classroom, I'm gonna post these 2 problems, and you can try them by yourselves. So before you guys leave, I just want to tell you that we have social media now. So in addition to the YouTube channel, which you can go to at youtube.com/ I believe it is Alphademic Learning. I believe this link will take you to our YouTube channel. You can also go to either Twitter, Facebook, or Instagram. And if you search at Alphademic L, then you'll be able to view our social media. So on our social media, we'll be posting whenever we launch a new class or whenever we have a lot of big announcements to make. So yeah, that's all I wanted to say. Okay, so A plus B equals 2 mod 3. Okay, so the reason it works is because, let me just go back there, hang on. So the reason it works is because if you sum all the digits in the first number, you'll get that 7 plus 4 plus 8 plus 5 plus 2 plus B plus 1 is a multiple of 3. So you'll get that A plus B has to be a certain thing mod 3. And you can't get exactly what A plus B is, but you can get the number A plus B, the remainder when A plus B is divided by 3. Does that make sense? Someone asks, can you post the Google Classroom code? So the Google Classroom you can sign up for on our website. So if you go to our website on ongoing courses, if you scroll down to Advanced AMC 8 problem series, and you click join and you fill out the form, it'll tell you the code. Okay, the website is alphademic.org, which is this.org. Okay, so if nobody has any other questions, then I'm just going to go ahead and close this room.